Hi, Thomas Spencer here. I will be focusing on if the mercury levels in smallmouth bass are posing a problem in the Chesapeake Bay tributaries. My research question: the mean mercury concentration in smallmouth bass in Chesapeake Bay tributaries is greater than 0.15 milligrams per kilogram. I use the 0.15 because that's the safe level of consumption for humans of mercury levels. The symbols, the mean is greater than 0.15, which would make my null hypothesis the mean is less than or equal to 0.15. My data source for this is the total mercury concentration in smallmouth bass from Chesapeake Bay tributaries, the USA dataset 2013 to 2017. The method of data collection was an observational study by scientists using electroshocking in order to take samples of smallmouth bass at sites in 9 watersheds within the Chesapeake Bay tributaries. Scientists collected a total of 294 smallmouth bass from the Chesapeake Bay tributaries. Summary of my data: the x-axis is the total mercury milligrams per kilograms recorded in the fish, and the y-axis being the fish count. Sample size N is 294, mean 0.218, standard deviation 0.135, and my minimum 0.039, quadrant 1 0.11, median 0.198, quadrant 3 0.294, maximum 0.977. The confidence interval: in conducting the 95% confidence interval of the population mean for the total mercury concentration milligrams per kilograms in smallmouth bass in the Chesapeake Bay tributaries, the confidence is between the lower 0.202998, upper 0.234063. This is concerning because both lower and upper are higher than the 0.15 milligrams per kilogram, the safe level to consume. Upon conducting the hypothesis test using the hypothesized value of 0.15, we have at a 95% confidence level, or alpha 0.5, the test statistic was 8.6836, and our p-value, the value of p, was 0.000 or less than 0.0001. The result is significant at p being less than 0.05. This result being significant, and if the p-value is less than alpha, then you reject the null hypothesis. The p-value equals 0.00 in this test, and it is less than the alpha, which equals 0.05. In conclusion, based on the hypothesis test results and our confidence interval, the result is significant at p is less than 0.05, and both the lower and upper confidence intervals being higher than our hypothesized level of 0.15. So we will reject the null hypothesis of mean less than or equal to 0.15 and accept our hypothesis level of mean is greater than 0.15, and accept there are significant mercury levels in smallmouth bass that are posing a problem in the Chesapeake Bay tributaries, which needs further testing and studying using same tools or more advanced tools. Thank you.